Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have a triangle ABC that is blocked by the circle. This is triangle ABC. We know that side AB of this triangle equals to 13 units in its length, side BC equals to 14 units, and side AC equals to 15 units. Our mission is to find out the area of this green shape. From the drawings it's very clear that the area of the green shape equals to the area of the circle minus the area of triangle ABC. In the next step, I will present to you a new formula for the area of any triangle. This will be rule number 4. So here we have triangle ABC. That could be any triangle. We know that the length of side AB is equal to A units, side BC equals to B units in its length, side AC equals to C units in its length. And we also know that the semi-perimeter of this triangle ABC, that is to say S, equals to the perimeter, that is the sum of its side lengths, that is to say A plus B plus C, and when we will divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of this triangle ABC will be equal to A plus B plus C over 2. S equals to A plus B plus C over 2. Side AB equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. So the area of this triangle ABC, according to this rule number 4, equals to the square root of S. S is the semi-perimeter of the triangle, that is equals to A plus B plus C over 2 times S minus A times S minus B times S minus C, all under the root. Okay, so we actually can implement rule number 4 in our drawing. So first of all, we define the length of side AB as A, and we know that A equals to 13 units in its length. We define the length of side BC as B, and we know that B equals to 14 units in its length. And finally, we define the length of side AC as C. We know that C equals to 15 units in its length. So I write it down here. A equals to 13, B equals to 14, and C equals to 15. In the next step, we'll calculate the semi-perimeter of this triangle ABC. The semi-perimeter S, according to rule number 4, equals to A plus B plus C over 2. Repeat again, the semi-perimeter of our triangle ABC is equals to A plus B plus C over 2. A is 13, B is 14, and C is 15, all divided by 2. 13 plus 14 is 27, 27 plus 15 over 2, 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC, the semi-perimeter S, equals to 21 units. Okay, S equals to 21 units. This is the semi-perimeter of our triangle ABC. So according to rule number 4, the area of this triangle ABC. We went in on here, that is rule number 4. According to rule number 4, the area of triangle ABC, here the square brackets is the sign for the area, so the area, this sign, this is the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. Okay. So the area of triangle ABC equals to the square root of S. S is 21. S minus A is 21 minus 13 times S minus B. S minus B is 21 minus 14 times S minus C. S minus C is 21 minus 15. All under the root. So the area of this triangle ABC, according to the new formula, is equals to the square root of 21 times 21 minus 13 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. Okay. So it is equals to the square root of 21. We'll substitute 21 by 3 times 7 times 8. We'll substitute 8 by 2 times 2 times 2 times 7 times 6. We'll substitute 6 by 3 times 2. In the next step, we will arrange the numbers here differently. So can I know that the area of triangle ABC equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. So actually we found out that the area of triangle ABC equals to the square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and the square root of 2 times 2 again is also 2. So the area of this triangle ABC according to the new formula of rule number 4 equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, we found out that the area of triangle ABC, our triangle ABC, that is blocked by the circle, it is equals to 84 square units. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. So actually, I found out that the area of this triangle ABC equals to 84 square units. Now we have also to find out the area of this circle, and we will subtract the area of the circle it is the area of the circle, the area of the green shape equals to the area of the circle minus the area of triangle ABC. So, in order to find out the area of the circle, I will present to you a new rule that is actually rule number 6, and we will implement rule number 6 in our drawing. In the drawing of rule number 6, we have a circle that blocks this triangle ABC. Side AB of the triangle equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. And according to our definition, the radius of this circle equals to R. So according to rule number 6, the radius of a circle that blocks triangle ABC, here this circle blocks this triangle ABC. So the radius R of this circle equals to A times B times C. This is actually the multiplication of the side lengths of this triangle ABC by each other over 4 times the area of triangle ABC. Okay? So actually can implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks triangle ABC. So according to rule number 6, we define the radius of this circle as R. Point O is the center of the circle. Point B is the point of the circle itself. Therefore, OB is the radius of the circle that according to our definition is equals to R. So the radius R of this triangle ABC that blocks the radius R of this circle that blocks triangle ABC, according to rule number 6, will be equal to A times B times C over 4 times the area of this triangle ABC. Repeat again. The radius of this circle that blocks triangle ABC according to rule number 6, so the radius R equals to A times B times C over 4 times the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. So the radius R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. And the area of triangle ABC equals to 84 square units. Okay. So here we'll divide both the numerator and the denominator of this expression by 14. So in the numerator we have 14, so 14 over 14 is 1. So after we divided the numerator by 14, we left only in the numerator with 13 times 15 over, in the denominator we have 4 times 84. So it is 4, and 84 over 14 is 6. So in total, after we divided the denominator by 14, we left only with 4 times 6. So here we will divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So in total, after we divide the numerator by 3, we left only with 13 times 3 in the numerator over, in the denominator we have 4 times 6. So it will be 4 times 6 over 3 is 2. So after we divide the numerator by 3, we left only with 4 times 2. 4 times 2 is 8. And 13 times 5 is 65. In conclusion, we found out that the radius of this circle R that blocks triangle ABC equals to 65 over 8 units. So I write it down. The radius R of this circle equals to 65 over 8 units. Repeat again. The radius of this circle R that blocks triangle ABC is equals to 65 over 8 units. Repeat again. The area of the green shape equals to the area of the circle minus the area of triangle ABC. I write it down again. The area of the green shape, from the bottom it is very easy to see that the area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. So the area of the green shape equals to the area of the circle. The area of the circle equals to pi r squared minus the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. The area of triangle ABC equals to 84 square units. And the area of the circle is pi r squared. So it is pi times r is 65 over 8. So r squared is 65 over 8 squared. Minus the area of triangle ABC, that is 84 square units. So this expression in total, pi times 65 over 8 square equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. So actually 207.394 minus 84 equals to 123.394 square units. So actually we found out that in total the area of the green shape equals to 123.394 square units. Repeat again. The area of this green shape, according to the first method, equals to 123.394 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we'll do a construction, that is to say from point A, we draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in BC as M. We define side AM as H. We define side BM as X. So, what is the length of side CM? From the drawing, it is very easy to see that CM equals to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. So I write it down that CM equals to 14 minus X units in its length. So in the next step, I will copy the right triangle, triangle A and B in a new page, and we will implement on this right triangle, triangle A and B the Pythagoras theorem. Okay. So actually, this is triangle A and B that I copied from the original drawing. AM equals to H and BM equals to X according to our definition. And it is given us the equation that side AB equals to 13 units in its length. Okay. So here by PT is the evaluation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169. And it is equals to AM square. AM is H, therefore AM square is H square plus BM square. BM is X, therefore BM square is X square. So actually found out that according to equation number 1, 169 equals to H square plus X square. Here we subtract X square from this equation, equation number 1. And we get that according to equation number 1, H square equals to 169 minus X square. In the next step, I will copy the right triangle AMC in a new page and we will implement on this right triangle AMC the Pythagoras theorem. So actually, this is the right triangle AMC that I copied from the original drawing. AM equals to H according to our definition. We have already found out that MC equals to 14 minus X and AC equals to 15 units according to what is given as the question. So in this right triangle AMC, we will get that AC square, this will be equation number 2, AC square equals to AM square plus MC square. I repeat again, in this right triangle AMC according to the Pythagoras theorem, we get that AC square equals to AM square plus MC square. AC is 15, therefore AC square is 15 square, that is 225. And it is equals to AM square. AM is H, therefore AM square is H square plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. Okay. So here we subtract 14 minus X square from this equation, equation number 2. And we get that according to equation number 2, H square equals to 225 minus 14 minus x squared. This is according to equation number 2. While according to equation number 1, we already found out that h squared equals to 169 minus x squared. Okay, so we actually have two different equations or two different expressions for h squared. Therefore, we'll create equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. So h squared according to equation number 1 equals to 169 minus x squared, and it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So if I find out that according to equation number 3, 169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So if we found out that according to equation number 3, 169 minus x squared equals to 225. Here we have minus before the brackets. We will open the brackets here, and we get that we will have here minus 196 minus x squared. Minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation. So minus x squared will get cancelled. So after we cancel the minus x squared, in this side of the equation we left only with 169. That is equals to 225 minus 196 equals to 29 minus 29 plus 28x. So here we'll subtract 29 from this equation, equation number 3, and we get that 169 minus 29 is 140. That is equals to 28x. So here we'll divide this equation, equation number 3, by 28. And we get that according to equation number 3, x equals to 120 over 28 is 5. So we found out that x equals to 5. But according to equation number 1, we have already found out that according to equation number 1, h squared equals to 169 minus x squared. So h squared equals to 169 minus x squared. X is 5, therefore x squared is 25. So it is minus 25. 169 minus 25 is 144. So in conclusion, found out that h squared equals to 144. So already known. So here we take a look out of this equation number 1, and we get that according to this equation number 1, A equals to the square root of 144, that is 12. So actually found out that AM is equal to H, it equals to 12 units in its length, and X equals to 5 units. In the next step, we define the center of this circle as O. This is the center of this circle, defined as O. And we'll join points O and A together by a straight line. Point O is the center of the circle, point A is the point of the circle itself. Therefore, OA is the radius of this circle. We'll define the radius of this circle as R, so OA equals to R. In the next step, we will extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO and the circle as P. We extended the radius AO, that is absolutely a straight line, by straight line. When you extend a straight line by straight line, the result must be a straight line. Therefore, AP, the result AP is a straight line, but AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes through the center of the circle, that is to say, it passes through point O, that is the center of the circle. Therefore, AP is the diameter of the circle. Why? Because any chord that passes through the center of the circle must be the diameter of the circle. So you can write down here that AP is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. The radius is R, therefore AP must be equal to 2R. Here we know that point O is the center of the circle and point P is the point of the circle itself, therefore OP is the radius of the circle, that is equals to R. You can see from the domain itself that the diameter AP equals in total to R plus R, that is 2R. Okay? So, in the next step, we join point C and P together by a straight line. By joining point C and P, we actually created here peripheral angle ACP. This peripheral angle ACP rests on chord AP. Chord AP is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So this is rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. So in the drawing, we have peripheral angle ACB. This peripheral angle ACB rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB that rests on the diameter of the circle must be equal to 90 degrees. So you can see here, indeed, peripheral angle ACB equals to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Therefore, this peripheral angle ACP equals to 90 degrees according to rule number 7. So write it down. In the next step, I present to you rule number 8 and we will implement rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing, we have two peripheral angles. This peripheral angle ADB rests on chord AB, and we have another peripheral angle ACB, that rests on the same chord AB. And because of the fact that those two peripheral angles, they rest on the same chord AB, therefore they must be equal to each other. So if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. So actually we can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC. This peripheral angle APC rests on chord AC. And we also have another peripheral angle ABC. This peripheral angle ABC rests on the same chord AC. So those two peripheral angles that rest on the same chord must be equal to each other. That is to say, if peripheral angle APC equals to theta in its size, then the other peripheral angle ABC that rests on the same chord AC must be also equal to theta, according to rule number 8. Peripheral angle ABC must be also equal to theta, according to rule number 8. Those two peripheral angles that rest on the same chord AC must be equal to each other, that is to say, each of them are equal to theta. In the next step, we'll focus on the right triangle APC. On the right triangle APC, APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, we focus on the right triangle ABM. On the right triangle AMB, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we will prove that the right triangle ABM is similar to the right triangle APC. So I'll write it down. We'll prove that the right triangle AMB is similar to the right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to theta, therefore they are equal to each other. So I write it down, angle ABM in triangle AMB is equals to this angle APC in triangle ACP Repeat again. Angle ABM in triangle AMB equals to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually, this is angle AMB. Angle AMB, triangle ABM is equals to this angle, that is actually angle ACP, triangle APC. Repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle BAM. And it is equal to this angle, angle PAC. Repeat again. Angle BAM equals to angle PAC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in this right triangle, triangle A and B, are correspondingly equal to all the three angles in this right triangle, triangle APC. Therefore, we actually proved that those two right angles are similar to each other according to angle similarity rule. So I write it down. We actually proved that the right triangle, triangle A and B the right triangle, triangle A and B is similar. This is the sign of similar to the right triangle, triangle APC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that AB triangle AMB over AP in triangle APC is equals to AM in triangle AMB over AC in triangle APC. Repeat again. We derive that AB over AP equals to AM over AC. AB equals to 13 units in its length. AP equals to, AP is the diameter of the circle, that is equals to 2R. And it is equals to AM. AM is 12 over AC. AC is 15. If we found out that 13 over 2R equals to 12 over 15, here we cross multiply this equation. And we get that 13 times 15 equals to 2R times 12. So here we divide this equation by 12 and we get that 2R equals to 13 times 15 over 12. Here we divide this equation by 2 and finally we get that the radius of this circle that blocks triangle ABC, the radius R equals to 13 times 15 over 2 times 12. Repeat again. The radius R of this circle equals to 13 times 15 over 2 times 12. So here we divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15. So 13 times 15 over 3 is 5. So in total, in the numerator we have 13. After we divide it by 3, we left only with 13 times 5. Over in the denominator we have 2 times 12. So it is 2 times 12 over 3 is 4. So in total, after we divided the denominator by 3, we left only with 2 times 4, that is 8, and 13 times 5 is 65. So in conclusion, found out that the radius of this circle that blocks triangle ABC, the radius R equals to 65 over 8 units. And the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it again. The area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. So the area of the green shape equals to the area of the circle. The area of the circle is pi r squared minus the area of triangle ABC. What is the area of triangle ABC? The area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. Repeat again. The area of the green shape equals to the area of the circle, that is pi r squared, times minus the area of triangle ABC. The area of triangle ABC equals to the base, that is BC, times the height to the base, that is h, over 2. The radius of the circle is 65, the radius R is 65 over 8, so it is pi times R is 65 over 8, therefore R squared is 65 over 8 squared, minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12, over 2. Actually, this expression, pi times 65 over 8 squared, equals in total to 207.394 square units, and this expression equals to 14 over 2 is 7, and 7 times 12 is 84. So there, ABC equals to 84 square units. So 207.394 square units minus 84 square units equals to 123.394 square units. So In conclusion, it's found out that the area of the green shape is equals to 123.394 square units. Okay, so in both methods we arrive to the same result. I repeat again that the area of this green shape equals to 123.394 square units. Okay, so in the next step I will summarize the lecture. We start with the first method. In this lecture, we found out the area of this green shape. From the domain, it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Okay. So in the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units in its length. Side BC equals to 14 units in its length. And side DC equals to 15 units in its length. Again, our mission is to find out the area of the green shape. So here I presented to you rule number 4 and we implemented rule number 4 in our drawing. Rule number 4 talks about the area of a triangle. It gives us a new formula to calculate the area of any triangle. So here we have rule number 4. According to rule number 4, the area of triangle ABC. Here we have triangle ABC that could be any triangle. The area for side AB is equal to a unit, side BC equals to B units in itself, and side DC equals to C units in itself. And the semi-perimeter of this triangle ABC equals to the perimeter over 2. That is to say it is equals to A plus B plus C over 2. So according to this rule number 4, the area of triangle ABC according to the new formula equals to the square root of S times S minus A times S minus B times S minus C. Again, S is the semi-perimeter of triangle ABC that is equal to A plus B plus C over 2. So actually we can implement rule number 4 in our drawing. First of all, we defined the length of side AB as A, and we know that A is 13. We defined side BC as B, and we know that B equals to 14 units in its length. And finally, we defined the length of side AC of triangle ABC as C, and we know that C equals to 15 units in its length. In the next step, so here, repeat again, A equals to 13, B equals to 14, and C equals to 15 according to our definition. In the next step, we calculated the semi-perimeter of this triangle ABC. So S, that is the abbreviation for the semi-perimeter of triangle ABC, must be equal to A plus B plus C over 2. A is 13, B is 14, and C is 15, all divided by 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So actually found out that the semi-perimeter of this triangle ABC equals to 21 units. Again, A equals to 13, B equals to 14, and C equals to 15. So according to rule number 4, the area of our triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. S is 21, so The area of triangle ABC equals to S, that is 21. S minus A is 21 minus 14 times S minus B is 21 minus 14 times S minus C is 21 minus 15. So the area of triangle ABC equals to the square root of 21, and 21 minus 14 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. Okay, then we substitute 21 by 3 times 7, we substitute 8 by 2 times 2 times 2, and we substitute 6 by 3 times 2. And we got this expression. Then we arranged the numbers here differently, and we found out that in total the area of triangle ABC equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, and the square root of 2 times 2 is 2, and again the square root of 2 times 2, that is 2. 3 times 7 is 21, so it is 21 times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, found out that the area of this triangle ABC according to rule number 4, it is equals to 84 square units. Then I presented to you rule number 6, and we implemented rule number 6 in our drawing. According to rule number 6, rule number 6 talks about a circle that blocks triangle ABC that could be any triangle. So the radius of this circle R will be equal to, here side AB equals to units in itself, side BC of triangle ABC equals to B units in itself, and side AC equals to C units in itself. So according to this rule number 6, the radius of a circle that blocks triangle ABC, the radius R equals to A times B times C, that is the multiplication of the side lengths of the triangle by each other, over 4 times the area of this triangle ABC that is blocked by the circle. We actually can implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks this triangle ABC. So according to rule number 6, the radius R of this circle must be equal to A times B times C over 4 times the area of triangle ABC. And we already found out that the area of triangle ABC equals to 84 square units. So the radius R according to rule number 6 equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC, that is 84 square units. Here we divided both the numerator and the denominator of this expression by 14. So in the numerator we have 14 over 14 is 1, so we left only with 13 times 15. In the denominator we have 4 times 84. So it is 4 times 84 over 14 is 6. So in total, in the denominator we have 4 times 6. Then we divided this as both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So in total, in the numerator we have 13 times 5. In the denominator we have 4 times 6. So it is 4 times 6 over 3 is 2. So in total, in the denominator we left only with 4 times 2. 4 times 2 is 8, and 13 times 5 is 65. So in total, we found out that the radius of this circle that blocks triangle ABC equals to 65 over 8 units. Repeat again. The radius R of this circle that blocks triangle ABC equals to 65 over 8 units. From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and we only found out that the area of triangle ABC equals to 84 square units. So it is pi r square minus 84. R is 65 over 8, therefore R square is 65 over 8 square, so pi r square in total it equals to pi times 65 over 8 square. minus the area of triangle ABC, that is 84 square units. This expression in total equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 is 123.394 square units. So, in conclusion, we found out that the area of this green shape according to the first method equals to 123.394 square units. We finished with the first method. In the next step, I presented to you the second method to find out the area of this green shape. In the second method, we did the construction, that is to say from point A, we do perpendicular on BC. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in BC as M. Then we defined side AM as H and side BM as X. What is the ref of CM? From the domain it is very easy to see that CM equals to CB minus MB. That is to say CM equals to CB, that is 14, minus MB, that is X according to our definition. So in total CM equals to 14 minus X. Then I copied the right triangle A and B in a new page and implemented the Pythagoras theorem on this right triangle A and B. So this is triangle A and B that I copied from the original domain according to the Pythagoras theorem in this right triangle A and B. AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and is equal to AM squared. AM is X, therefore AM squared is X squared plus BM squared. BM is X, therefore BM squared is X squared. So in total we found out that according to equation number 1, 169 equals to X squared plus X squared. If we subtracted X squared from this equation number 1, and finally found out that according to equation number 1, X squared equals to 169 minus X squared. Okay, then I copied the right triangle AMC in a new page and we implemented the Pythagoras theorem in this right triangle AMC. This is the right triangle AMC that I copied from the original domain. According to the Pythagoras theorem, in this right triangle AMC, AC squared equals to AM squared plus MC squared. Repeat again, according to the Pythagoras theorem, in the right triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15. AC is 15, therefore AC squared is 15 squared, that is 225, plus AM squared. AM is X, therefore AM squared is X squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. So according to equation number 2, we found out that 225 equals to X squared plus 14 minus X squared. Here we subtracted 14 minus X squared from this equation number 2, and found out that according to equation number 2, X squared equals to 225 minus 14 minus X squared. This is according to equation number 2, while according to equation number 1, we have already found out that X squared equals to 169 minus X squared. So we have two different equations for X squared. Therefore, we created equation number 3 that states that X squared according to equation number 1 must be equal to X squared according to equation number 2. X squared according to equation number 1 equals to 169 minus X squared. And it must be equal to X squared according to equation number 2. X squared according to equation number 2 equals to 225 minus 14 minus X squared. So according to this equation number 3, 169 minus X squared equals to 225 minus 14 minus X squared equals to 14 squared, that is 196, plus X squared minus 2 times 14x, that is minus 28x. So according to equation number 3, we found out that 169 minus X squared equals to 225. We open the brackets here. So here we get minus 196 minus X squared, and minus times minus is plus, so it is plus 28x. So we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of the equation, after we cancelled minus x squared, we left only 569. In the other side of the equation, we have 225 minus 196, that is 29, plus 28x. Here we subtracted 29 from this equation, equation number 3, and found out that 169 minus 29 is 140, that is equals to 28x. Here we divided this equation, equation number 3, by 28, and finally found out that x equals to 140 over 28 is 5. So x equals to 5 units. And we have already found out that according to equation number 1, h squared equals to 169 minus x squared. So h squared equals to 169 minus x squared. But x is 5, therefore x squared is 25. So it is minus 25. So in total, according to equation number 1, we found out that h squared equals to 169 minus 25, that is 144. So according to equation number 1, we found out that h squared equals to 144. We took out of this equation and finally found out that h equals to the square root of 144, that is 12. Here, h equals to 12 units. Okay, in the next step, we define the center of this circle as O, and we join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle that we defined as R. Then we extended the radius AO by straight line until it touches the circle. We define the touching point as point P. When we extend the straight line by straight line, the result is a straight line, so AP is one straight line. But AP is one straight line that touches the circle at points A and P. Therefore, AP is a chord that passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. And any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius. So the radius is R, therefore the radius of the circle equals to R. According to our definition, therefore AP must be equal to 2R. Here again, we know that point O is the center of the circle, point P is the point on the circle itself, therefore OP is the radius of the circle, that is equals to R. So in total, you can see from the drawing itself that AP equals to R plus R, that is 2R. Then we join points P and C together by straight line. In this way, we created a peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that says that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing, we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB must be equal to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing, we have peripheral angle ACP that rests on AP, therefore, and AP is the diameter, therefore, peripheral angle ACP according to rule number 7 must be equal to 90 degrees. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. We have here two peripheral angles. The first peripheral angle ADB rests on chord AB, and the other peripheral angle ACB rests on the same chord called AB. So because of the fact that those two peripheral angles rest on the same chord, they must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle APC. This peripheral angle rests on chord AC. But we have another peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles, they are both rest on the same chord called AC. Therefore, they must be equal to each other. That is to say, if this peripheral angle APC equals to theta, then the other peripheral angle ABC also must be equal to theta according to rule number 8. In the next step, we focus on the right triangle APC. In the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle ABM. On this right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that those two right triangles are similar to each other. That is to say, the right triangle ABM is similar to the right triangle APC. Why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the right triangle ABM are correspondingly equal to all the three angles in the right triangle APC. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that AB in the right triangle AMB over AP in the right triangle APC equals to AM in the right triangle AMB over AC in the right triangle APC. I'll repeat again. You can derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle, that is 2R, AM is 12, and AC is 15. Here we cross multiply this equation and found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12 and found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and finally found out that the radius of this circle that blocks triangle ABC equals to 13 times 15 over 2 times 12. And then again, the radius R equals to 13 times 15 over 2 times 12. So we divided both the numerator and the denominator of this expression by 3. In the denominator we have 13 times 15, so it is 13 times 15 over 3 is 5. So in total, after we divided it by 3, we left in the denominator with 13 times 5. We divided the denominator also by 3, so it is 2 times 12. After we divide it by 2, we get that it is 2 times 12. After we divide it by 3, we get that in the denominator we have 2 times 12 over 4. 2 times 12 over 3 is 4. So after we divide it by 3, in the denominator we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So we can found out that the radius R of this circle that blocks triangle ABC equals to 65 over 8 units. And the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and the area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is AM over 2. Repeat again, the area of triangle ABC equals to the base that is BC times the height that is H over 2. So it is, the area of the circle is pi r square, but R is 65 over 8, therefore R square is 65 over 8 square. So in total, the area of the circle that is pi r square, it is actually equals to pi times 65 over 8 square. Minus the area of triangle ABC. The area of triangle ABC equals to BC that is 14 times H that is 12 over 2. So in total, this expression equals to 207.394 square units. And this expression in total equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC equals to 84 square units. and 207.394 minus 84 equals to 123.394 square units. So in conclusion, we found out that the area of this circle in both methods is equals to 123.394 square units. Okay, thank you very much.